Okay, so I'd just like to welcome everyone. We're going to kick off. Give you a second to get organized. Whoa. So there's a lot of faces out there. So number one, I'd just like to say welcome to everyone who's come this evening. My name is Donal. I'm one of the organizers of iNOG. There's also Cristian, who's floating around. And you're in RiotGames tonight, which is, I think, obvious from signing the NDA. Thank you very much for coming to iNOG. For those of you who are new to iNOG, iNOG is a little bit of a, I suppose, an unconventional or non-traditional network operators group. So we have quite a wide remit in terms of the talks or the interests that we have. One of the things that we really try and focus on here is we really try and capture the knowledge and share it out in a digital format. So there will be photography, some photography this evening, and some video recording. If you have any issues with your image being on a camera or like being on a picture or being saved for posterity, please let one of us know, myself, Cristian, pretty much anyone with a Riot badge or a Rioter, and we'll make sure that you get pixelated or taken out. A little bit of housekeeping. Please stick your phones on silent or in airplane mode just while there's talks going on, unless you've got a major emergency or something in the wings. When we're doing questions, we really would welcome questions. We have a thing called a catch box or a catch cube, which we're going to throw around the room. So if you wait until that gets to you, it's actually a microphone, so you can speak to that. Please just give us your first name, just so we know who you are and the presenter can address you directly. Okay, the other thing we have in iNOG is the code of conduct. We're quite focused on trying to build a sort of a safe and welcoming environment. So if you'll indulge me very quickly, our code of conduct is available in its full form on the website. It applies to these meetings and pretty much any interactions within the nascent community or the burgeoning community. The short version is, it's kind of Bill and Ted style, be excellent to one another. But a slightly more long form is our group is dedicated to providing a friendly, safe, and harassment-free experience for everyone, regardless of gender identity and expression, age, sexual orientation, disability, physical appearance, body size, race, ethnicity, religion, or lack thereof. And there's a longer version that we've adopted on the codeofconduct.com website. So just FYI. Please give us a tweet. Use the hashtag at iNOGnet. Post some photos if you can. We're going to have 3 talks tonight, one from Jose, one from Jason, and one from Rodrigo. We're always canvassing talks, and we really want to, we want to have a more diverse representation. So if you know anybody who is willing to give a talk or is interested or has a topic they'd love to share with us, we'd really like if you put them in contact with us, either through Twitter or through the website. That's pretty much it.
So first things first, the podium selfie. There you go. And thank you very much to the iNOG folks and to Riot for hosting. Essentially, I'm going to present a story of the fun that is multi-vendor and essentially troubleshooting. So hopefully this won't take 3 hours, and I have my notes to rely on if I start mixing acronyms because I'm terrible at them. So let's get going. I usually give this presentation with Said. Said was a big part of this investigation, but he's in California today, so you're stuck with me. And essentially, we're going to be talking about a little bit about the Facebook scale and topology because it's relevant to the talk. I find that it always gives a sense to folks about what's the actual size of our network and how many users rely on it. The actual investigation and how we went from there's a problem to this is the final solution that's going to fix this forever for us and everyone in the world that happens to run MPLS. And we are tweaking the volume. That's fine. I'm very loud. It's a good job. Actually fixing the problem. What are some of the lessons learned? And the fun part, which tends to be the Q&A. So Facebook scale and topology. And I'm supposed to look at this because it's the one that's closest to me, so I'm going to look at this. Yes. So these are numbers as recent as of June of 2016. And the interesting numbers here I'm probably going to start using this, is essentially the monthly active users and the mobile daily active users. It's over 1 billion people for mobile, and it's over 1.7 for monthly active users. And the bit that's most interesting for me is that 84.5% of those are essentially outside of the US and Canada, right? This means that for our network, we typically have the traffic patterns are common for web companies where the lower curve tends to be machine to user, so it tends to be the traffic to those billions of people, which tends to continue to grow, but it grows at a pace that's easier to control. The really interesting traffic patterns tends to be machine to machine, so that relies heavily on the backbone for a multitude of reasons, and is what enables the rich experiences that we can have today on Facebook and Facebook-related products, right? So now let's talk about the topology. And this is a very high level, very simplified, very, very, very high level topology from top of the rack all the way to the edge of the network. So we have essentially clusters, and clusters are essentially a collection of racks. They are interconnected by a DC network. Depending on the generation, it's either one of our closed topologies that's described in our blogs and other presentations, or it's the older generations with things like 4-post. There are typically routers that we designate as a data center router. That's what DR means, and those are the routers that provide connectivity to outside of the data center, right? They connect to the magical backbone, which is the part of the network that we're going to be spending most of our time today, and essentially this is a typical MPLS network. So, in service provider lingo or in vendor lingo, the DRs would be your PEs, and the backbone devices, the BB devices, would be your P devices, right? And then we have POPs, and essentially the devices that are on the POPs, typically we call them PRs, which is peering routers. They also act as PEs, and they provide the connectivity to the backbone, and they provide the connectivity to the edge of the network or the internet, right? And this is like a very high-level view from top of the rack all the way to the edge. The protocols that we use in this backbone are pretty straightforward. Nothing mystical here. Nothing super mysterious. Essentially, SIS, BGP, RSVPT, mostly for auto bandwidth, because it solved a problem that we had when we were building the backbone, and it works very well for our use case, and yeah, it's awesome, right? So nothing mysterious there. We have 3 types of LSPs, and those, going from the ALSPs all the way to the S and SF LSPs. The ALSPs tend to be the lower priority LSPs, so they can get bumped by the other 2. The only difference between S and SF LSPs is that the SF LSPs have FRR enabled. They are supposed to be used for the most sensitive traffic, for the traffic that in case of failure, in case of the shark eating the fiber, essentially they have to reconverge, and that promise of the 50 milliseconds that FRR should provide, right? So, some background. So what about this investigation? How this story starts? This story starts with this graph, right? And this is essentially a graph of packet loss. And I imagine it cannot be read, but at the bottom you can get a sense of the time frame of this, and it's around 12 hours, right? Or it's around less, around between 10 and 11 hours. And this is essentially a graph of packet loss that, interestingly enough, is only for the LSPs that have FRR enabled. So, it's exactly where you don't want to have packet loss. You can sustain packet loss, or your agreement with service owners is like if your traffic is marked as you need to go in the ALSPs, you're going to get bumped, and you are supposed to be fine with it because it's bulk traffic or whatever it is. But things that use FRR are supposed to be protected, and this should never happen, especially for hours, right? So, not good. So we jump and start investigating this, right? So we rely on, this is active monitoring, of course. This is synthetic traffic that's telling us this story. We start looking at the passive monitoring, start looking at the classical, counters and such and all this good stuff. And we get, these are the top 5, top 10, top X devices that are dropping packets. And we have the ability to capture what are the packets that those devices are dropping. So we say, okay, so you're dropping these packets, let's figure out why, right? So we start looking at the payload to see if this is a new, mysterious, sexy application that doesn't conform with any standard known to networking, but we weren't that lucky, right? So we start looking at this. The payload looks, amazingly normal and, super varied. So we go, obviously, it's not the payload. So we start looking at the labels, because that's another thing that the passive monitoring told us. The passive monitoring told us that, essentially those packets are getting dropped in those devices because, there's some sort of MPLS issue, right? So we start investigating the labels, and the early findings of this told us that, hey, those packets are getting dropped because they have an invalid MPLS label. So we go, okay, that's not good. Immediately what comes to mind is some sort of RIF inconsistency. you have some sort of mismatch between control plane and forwarding plane. Why is this happening, right? So we do what most people would do in this scenario, which is, okay, we have the data from the active monitoring that essentially pinpoints this or gives us, this is a source destination that produces the biggest loss. So we decide to go after that, and we start doing active probing. We essentially start doing MPLS pings. We start doing this over each LSP that interconnects those 2 points, and very quickly we find the source, or we find a series of LSPs that whatever traffic you put in them is essentially black hole, right? Which is not good. But it's a great place to continue looking. And based on our monitoring, on our analytics tool, we can paint the picture between those 2 points. And this is a graph that I'm going to use for most of the presentation, right? We picked a single LSP and we dissected that LSP and we, established this exact same graph. This graph, obviously I changed the host names because, one, it's simpler to say this than our actual host names. And two, it's simpler to say, label all threes than to say, the actual labels. But we dissect a single LSP and we figure out what's happening, right? So we looked at historical data that told us, this is how the LSP looked like when everything was happy, right? So when there was no packet loss there. And essentially, the other interesting bit that we got from this is that this loss was only on FRR-enabled LSPs, and it was only on LSPs that were going between POPs, right? So we start looking at this and we go, okay, so when it looked like this, everything was great. So what changed? And when we look at what changed, we find essentially this version of this. I'm going to go back to my super official pointer. I'm going to make this my pointer for all my presentations. So we essentially find that there's an event in BBO1X3, right? There's an event, there's a fiber cut because a shark ate a fiber or whatever it is, or some military exercise blew up a fiber cable, I don't know, the typical stuff. And when this happened, FRR did what FRR is supposed to do, which is put you in a bypass LSP, right? Which is this path down here. And when that happened, this is the status that we actually found the devices in and we actually found the LSP in, right? This happens, you go into this bypass LSP, that's the path down here, and the merge point, which is the device here, is BBO1E2, is essentially dropping packets, right? So we get a couple of interesting pieces of information from this, right? We get that, the trigger for this was this fiber event, we get where we're dropping packets, and we also get the super, the super abnormal thing, which is after hours, we're still in the bypass LSP. This is not how things are supposed to go. You're supposed to be in that LSP until, constraint shortest path first figures out where to put you, and life is great again, right? In this case, for whatever reason, after hours, we are still in the bypass LSP, which doesn't explain necessarily why would you have loss. At the end of the day, it's not optimal and it shouldn't happen, but you should be able to send traffic over the bypass LSP. If not, it would be pretty useless, right? So with this information, we go and we do all the investigation with the vendors and all the lab reproduction, because at the end of the day, our backbone network is multi-vendor, so we have multiple devices and software, et cetera, running there, and we figured out what actually explains all of this, and I'm going to go over this in a minute. So, bug number one, RFC 4090, which is essentially the FRR extension RFC for RSVPTE, tells you that in the case of a protected LSP failure, right, you have two strategies to fix this, right? And strategy number one is using global revertive mode, where essentially the responsibility lies on the headend. The headend is supposed to do this based on some input, typically path errors or some other form of message that tells the headend, hey, there's a problem, you need to figure out, you need to put it somewhere, right? You need to recalculate. Or you can use local revertive mode, right? All the platforms that we have, by default, use global revertive mode, right? So that's, this is important to know, because essentially bug number one is that global revertive mode was broken in one of the vendors. And the interesting thing here is that vendor one essentially has an internal flag for each LSP that I decided to call awesome flag for the presentation, because if I actually put the name of the flag, you guys would figure it out, and then the vendor would be sad and not good, right? So yeah, I probably sue us. So I'm going to call this awesome flag. And let's say the purpose of that flag is to indicate that the current path may be used by a bypass tunnel, and you shouldn't take it into account when doing constrained SPF, right? So this is the normal state. Let's say that this flag is set to true, right? So the event happens when the headend receives a path error message for that particular LSP. This flag gets turned into, it gets switched, right? It doesn't matter what it gets switched to. Let's say, for the sake of argument, it gets switched to false, right? And then what everyone expects happens, right? you go through your bypass, and in the meanwhile, you have shortest path first going, right? So what happened here is that the theory is that this flag gets put back into in the normal state after you have make before break, after you have said, like, this is done, and it tells you, like, this is the greatest path that you should put this LSP now on, now that this is, no longer there. And in this case, they had a race condition. And essentially what happened in that race condition is that flag would get put back into the normal state without waiting for the make before break. And that, essentially would tell the device, hey, dude, the path that you're using now for that LSP is the greatest path ever. So no other calculation from constraint shortest path first is really taken into account. Everything is awesome for hours, right? So there's no reoptimization. There's nothing, at least, or there's a very, very, very few scenarios that actually take it out of that state. So that explains why we were stuck in FRR, right? So this is an easy fix. The fix here was essentially, don't set the flag until a make before break happens, right? That explains why we were stuck in FRR, right? That didn't really explain why we were having loss. So we were having loss, and this is the super interesting part, is because there was an in-flight label change, and this was not honored by the point of local repair. So something to take this into account is that we use next hop protection, right? So like when this happens, essentially, you're only bypassing a single node of the protected LSP during a failure. And to move traffic around, use the magical pointer again. To move traffic around in your bypass LSP, you use a global MP label, which is this label right here, and then to move traffic in the bypass LSP, you use a transport label or the FRR label, however you want to call it, right? So what was happening here? There was an in-flight label change, right? And that label 11111 is no longer valid, and now we have a new label, right? So interestingly enough, the PLR is supposed to figure this out, right? The problem is that in the RFC, in 4090, it specifies how you're supposed to do this, and how you're supposed to do this is that you're supposed to use information out of the RRO, but it's only specified for the actual protected LSPs. It's not specified what you're supposed to do for the backup LSP, right? So since this is not defined in the RFC, each vendor has their own magical way of doing this. And in this case, the vendor that was BB01X3 didn't expected this to be in the RRO, and it wasn't being put there in the RRO by the merge point, which according to the RFC is a valid behavior. So what was happening was now that label changed, and BB01E2 is expecting to get traffic with that all sevens label, and the point of local repair is sending traffic essentially with a stale label. So all the traffic that's getting there, the device is saying, like, this is great, I have no idea what to do with this, so you're getting dropped. And since when you combine that with the other bug, you're essentially stuck in a path that black holes forever. Which is, I jump ahead, but yeah. So the fixes here, we basically got them to, play along, and each vendor kind of did their own fix, and essentially vendor number one is easy to fix, is essentially add this to the RRO. And we got vendor two to actually extrapolate this data from the RRO if possible, right? Like if there's another address present that belongs to the MP, extrapolate what label you should be using here. And this essentially explains this situation that we were having, right? So what are some of the lessons learned out of this, right? So obviously lesson number one is multi-vendor is hard. Like we made the decision to use multi-vendor in multiple places around the network, or in most of the network, because it gives us a lot of benefits, and it gives us a lot of flexibility, and it allows us to minimize risk, especially because we tend to be on the bleeding edge both in software and hardware, just because we have needs regarding features, or we have needs regarding capacity, where the only way of running the line card that produces all the terabits is to run the latest strain of code, right? So, that strategy works for us, right? But this means that we have a series of defenses, and we have a series of layers to ensure that we qualified all of those components as much as possible, and that we qualify that they play along nicely, right? And this, obviously, is more important in like critical features such as FRR, right? Like, in fact, after this, we obviously adjusted how we were doing our testing, and we tweaked all of this, and we actually found another day one situation with one of the vendors where essentially the PLR, or essentially the merge point, will change the label. Well, the merge point will change the label, and he wouldn't notify this downstream for 50 seconds, right? So this even affects, forget about interop, forget about multi-vendor, this even affects, that same vendor. Because for 50 seconds, anything that's downstream has no idea to know, hey, that label changed, right? The second lesson was that failure doesn't necessarily equal impact, right? Like, as we have matured over the years, NetNORAD has produced more and more relevant data, in the sense of, in the beginning, NetNORAD, there was always a conversation of like, is this actually real? Like, do we actually believe this? Which would be, in this particular scenario, it's a perfect use case, because you go like, there's only loss in a particular LSP type, that this must be a bug in the active probing, right? Like, this makes no sense. Like, if you had a hardware failure, you would jump into the conclusion of, there's a hardware failure, it should affect all LSPs, right? It shouldn't affect a single LSP. Like, it's quite unlikely that, but like, as we mature that tooling, like here, that wasn't even a question. Like, we started digging into the network, and we immediately found the network to be at fault, right? And as we continue to develop this, we find this to be true more and more and more, right? So like, the interesting bit here is that we had seen this type of failure, maybe not as pronounced as this. We have seen similar failures where, like, there was a janky behavior in some features, so we have failures where we lost terabits of capacity, and essentially the network didn't recover as we expected. It didn't recover as fast as we expected, and we assumed that this was normal, or we investigated. In one of the cases, we actually did a reproduction that took down the terabits of capacity again, but like, it was hard to pinpoint, right? And this ties into the third one, which is collect all the things, right? Like, at the end of the day, it's not only about making sure like the vendors actually interop. It's not about like this can all pass all of our testing criteria. It's about ensuring that can you actually with confidence say that FRR or any other critical feature that you have is behaving as expected when you release this in the wild, right? And most of the time, this requires depending on what the feature is, requires a lot of tooling and requires a lot of elements that aren't there, right? Most vendors don't really have a good way for you to like monitor. Even a backbone network, with a simple feature set like ours, right? So we had to spend a lot of time developing this, and obviously monitoring end to end. Like, for example, we took the lessons, or we took some parts of the troubleshooting scenario that I just described, and we integrated them into the alarming, right? Or we integrated them into the monitoring as another input, right? Like, we had the end-to-end input from NetNORAD, but for example, we never did the let's monitor or let's try to generate synthetic traffic over every single LSP the same way we did in the troubleshooting. So we integrated that into the solution, and we now have more information to determine this type of situation, whether it's because we have bad hardware, or whether now FRR is broken in another release, right? That's all for me. Thank you very much. Let's go to Q&A. I'm gonna drink some water.
1, 2, 1, 2. Okay, thank you so much, Jose. We've got a catch cube. If anyone's got a question, can you just give us 1 second?
I think you need a microphone so you can hear in the recording.
Good catch. I talk out of this thing? Oh, okay. Jose.
Speak into the box, dude. Let the box guide you.
So, Jose, when you're talking about your network design, I mean, how much of it is around hardware and how much of it is around software in terms of label switching and QoS? I mean, in terms of the vendor dependencies, sort of where does the sort of the design depend upon, where deep buffers can make a difference versus where quality of service can make a difference?
I mean, it depends on your application, right? Like the whole debate of I'm not gonna say what I was gonna say. The whole debate of if deep buffers matter or don't matter really is the engineering answer of depends. At the end of the day, it depends on your application, right? Like, if you have an application that benefits from that, then yeah, deep buffers are awesome. If your application gets out of whack because you have deep buffers, then you don't want to have deep buffers, right? So, I mean, in general, and this is my personal opinion, so don't take it as the Facebook gospel. That's my personal opinion. Is that if we want sustainable networks in the future, we should move into as simple as possible designs and as simple as possible hardware, right? I mean, in my personal experience in my career, the more horrible experience I had with vendors, hardware, etc., has always been because you've taken a device. You picked a device because probably it has the most capacity available on the market. And this is a device that the vendor, obviously because they want to sell millions of them, has made it do 1,001 things. And the reality is that you need them to do only one thing very, very well, right? And that tends not to happen because, again, their focus is different from yours, right? So, the simpler your feature set, which here is quite simple, right? The simpler your feature set, the more choices you can have in terms of hardware, and the more flexibility you have in terms of hardware too. You're using ASIC X, and ASIC X doesn't do what you want, or you're using vendor X, and vendor X doesn't do what you want. If everything is sort of standard, and you can very easily port to another thing. Where if you are depending on all the magical knobs that a single ASIC can do, then you are stuck there, right? I don't know if that answers the question or not.
We'll do another, I think, 2 questions, and before we move on. Yeah.
Hi, Julian. Just a quick question. You mentioned there was, in a sense, a lacuna in the RFC. If you stepped back from your reactive testing
put this.
and ordered made an index of all the RFCs you rely on, the critical ones, could you have seen that ahead? And should you have been testing getting your vendors to test their implementation of our RFCs?
I mean, it's complicated, right? Like, I think the reason why this is not in the RFC is not necessarily because the RFC is bad. The RFC is awesome. It's because, like, this is, at the end of the day, a corner case. It's not a corner case. It's similar. I always use the example of like an airplane crash, right? Like, if you look at, I really like to watch Mayday and like those shows. And most of the time, it's not like, oh, there was a hole in the plane, so it went down, right? It's always like, oh, there were 20 small things that eventually end up in the disaster, right? As you can see here, it's like 3 or 4 different things, and when combined together, because like the interesting thing is, like, you forget that you're stuck in FRR. If you weren't stuck in FRR, this would be a blip, right? Like, something happens, like you get out of FRR quite quickly, because that's what happens. I mean, all of our networks, or our network at least, has quite enough capacity to survive the sharks eating the fiber, or survive the military blowing up the submarine cable and all that stuff. So you get out of that situation quite quickly, and you see a bump, but you go like, well, like, depending on your level of monitoring, you blame the shark for this, right? But it's a combination of things, right? So, I mean, and in this particular case, yes, when we hardened the testing, when we when we started doing much more aggressive testing, which is I'm a huge fan of, I always say the same thing, which is test until the device melts. We found, for example, the 50-second situation, right, which is day one, and probably is happening in networks all around the world, and people, because it's a blip, right, because it's a 50-second situation and then it disappears, it's a classical thing where a human is not fast enough to, by the time a human has like, oh, there's a problem, I need to go look at it, this is long gone, right?
Thank you.
So if maybe we can pause that one. Is that all right? And you can grab Jose after. And what we'll do is give Jose another round of applause. Thank you very much indeed. And we'll just do a quick swap over to Jason, who's going to talk to us about network automation with Ansible.
All right, good evening, Ireland. So if you can't tell, I am not local. I'm not from Ireland. I am from the United States, born and raised in New Jersey, work out of downtown Manhattan, and day-to-day do a lot of network automation. This is my 3rd time, actually, in Dublin in the past year, which is great, doing a lot of training courses, automation-related, Ansible-related. We'll dive into that tonight. But first things first, everything I'm talking about tonight in terms of the material, the content, the slides, we're going to have live demos in terms of playbooks and Ansible. It's all currently on GitHub already, and the link will be hopefully provided after the meetup. But everything's going to be at github.com/network-to-code/iNOG9. Everything there, even the slides, all the slides are written in Markdown that we can do a git clone and have all the slides available. Okay. All right, cool. So network automation. So what does this mean? Why do we need it? I'm going to try to get rid of my status bar on the bottom. It's been giving me problems all day. These guys know over here. All right. Let's do a refresh. Yeah, I can't find the actual trick every time. Oh, got it. Yeah. Where's it? Got it. No, you're saying lock? Properties, got it. It's been a while, everybody. Auto hide. All right. Don't do math on stage or work in Windows, right? Okay, cool. All right, so network automation. I don't have too many slides. Really want to kind of focus on live demos towards the end. A lot of times I would do presentations and focus on why automation, trying not to focus on the why. I think by now it's kind of obvious. Most of the examples that are talked about are about configuration management, right? So the types we want to talk about tonight, not really targeting config management. We have them on the list, but in general, we want to focus on different areas of automation that make sense for networks of all shapes and sizes, right? Not everyone has massive scale, right? These MSDCs that exist out there have thousands of nodes, so configuring things faster actually make a huge impact. But coming from my backgrounds right back in the States, a lot of former customers are fairly small in size, right? They might only have, a few different sites. It could be, a legal firm that has a dozen sites globally. It might be a university with a few larger buildings. So needs vary all in all, but in general, there's typically use cases that could make sense based on any given environment, but it usually does boil down to the current workflows that the network engineer has, right? It could be day to day, again, anything from, checking serial numbers to, you're doing an upgrade or, a change out of contract renewals of support, right? It could be a SmartNet or, whatever it's called based on the vendor. And I remember, in years past, serial numbers, from a show version would have one of the serial numbers. So, it could be an automation task to, collect serial numbers for every module, or it could be to do a configuration, not necessarily faster, but the nice thing is you would, vet your script or your tool once and ensure it'll always be predictable, right? So scripts will not fat finger a change, which is nice. So it's either all going to work or it's all not going to work, right? You're not gonna. I remember, in cutovers, years past, there was SVIs and multiple, on 2-core switches, right? And VIPs, HSRP, they were just forgotten about on like 3 out of 20 VLANs, right? Those things really wouldn't happen if you're leveraging some form of automation. Right, we have device compliance though, so tonight we're going to look at some compliance checks in terms of ensuring certain things are true or maybe false given an environment. Maybe you just want to do an assertion to ensure a certain version of OS or a certain group of OSs exist in the environment. Maybe you want to ensure a certain version is in the data center, on the WAN edge, AG, and so forth. Or it could be you want to ensure there's a security team coming in. You want to ensure that a certain AAA IP address is being used, or certain local user accounts on the box. So all these things, they seem kind of trivial, but in general, when it comes down to it, those things are typically manual. They don't happen day to day, but when they happen, they're usually critical, and it takes hours on end to mitigate it or do those types of checks, right? Data collection, mentioned serial numbers, things like that. But even adjacencies, and a lot of this can be used for different use cases. So it could be data collection of basic things like serial number, or even neighbor checks. So tonight we're going to see a live demo of neighbor checks, where if you've ever done any kind of deployment overseas. Back in the US, let's say you might hire subcontractors to do cabling. I was part of a large build out of a hotel in Atlantic City, New Jersey. There was it was a large build out, and there was union workers, back home that were hired to do the cabling, and there was a lot of bad cables that went in from the patch panels into the wiring stackable switches. So we didn't find out until IP phones in the rooms and things like that didn't work. So there could be automated ways, or there are automated ways just to do cable checks. Is the cable deployment accurate? The hard part there is the upfront work to define what it should be in some sort of structured data format, right? So take it from maybe an Excel or a CSV file and be able to import that into some code, and then be able to compare that to a real-time neighbor check, right? And even that model can go down to the host in the data center. So a lot of vSwitches today, right, from vCenter, OVS, run LLDP. So we can do those kinds of checks, across the network. It could be, again, backbone, internal, data center, what have you. And config management, right? This is the obvious one. Again, the key here is not just about configuring things faster. Like it really is, being a bit safer about how things are done in any size environment. Okay. So getting started, right now, again, the title of the talk, right? I'm a little bit, biased. We all have our personal, favorites, but in general, there's kind of 3 core options. One is native programming, native pure software development. Other ones, open source tools, right? Lower barrier to entry. Or 3 is, hey, you just want to buy something from your favorite vendor, and hopefully it works, right? And there's pros and cons for each one of these. Just a matter of, is there the staff, or the know-how, or the ability to do any one of these? And native programming, right, probably should be the rarest one out there for the non-web scale companies, right? And again, it's personal opinion. It's just a matter of, is there a team of developers to build a custom tool from the ground up, or can we use an open source tool that gets you almost all the way there, that you can extend or program to yourself to, if it can't automate a feature that you want to automate, then kind of extend that feature yourself. And we'll talk about how I did something this week just for this demo there. Or commercial tools, right? A lot of times commercial tools are just pure expensive, right? And just a matter of, if it's open and extensible, then it could be worth it. But just really look at the trade-offs for each one. So we'll look at support, control, and extensibility. So a lot of folks now are looking at open source and putting in a little custom development, because it does give you a lot more control over the environment, and it allows you to add an extension if needed versus waiting for the vendor to deliver that feature, right? One more thing. So be the automator. Don't be the automated. There's a lot of fear out there, and I think we're in a great time for the next probably couple of years with automation. And the key really here is to be the one doing the automating, and it's not going to happen overnight. This is going to take 3-5+ years. Even a lot of companies have deployed automation already, but in general, before it hits the true mainstream, like there's still years ahead. And so just keep in mind, be the automator. Okay. All right, cool. So I have 3 mini demos to go through tonight. All right, 2 of them are with Ansible. 1 is with Postman. All right, have folks here heard of Ansible and/or Postman? All right, cool, good mix. All right, so the first 2, again, one of these is config management. The first one is automated cable verification, and the third one is a look at a newer API from Cisco on iOS XE. All right, so we're really trying to target different. We're looking at Juniper, we're looking at iOS XR, we're looking at iOS XE. We're really trying to keep it vendor neutral across the board. Okay, and the nice thing is all these VMs are currently in the public cloud. They're hosted, I believe, on the East Coast right now in the United States, and they're all VMs, right? So the nice thing about automation, it was always hard to get these lab devices in the past, but right now we're using iOS XR-V, CSR 1000V from iOS XE, and the VMX from Juniper, right? So most vendors these days have virtual appliances, right? There's VUS from Arista, there's virtual firewalls, there's a lot of them out there, and one of the primary use cases is really to get started on automation. You can build a pretty robust topology, with these types of virtual machines. Okay. Yeah, so before the demos, just real quick, a few words about what we're gonna look at, because there's some newer terms, some tools. Ansible, again, OpenConfig BGP is being mentioned here, so I'll take a second to describe some of what's going on with OpenConfig. Ansible, this is again keeping it real short. Ansible's pretty robust, great platform overall. I don't consider it a tool per se, but it really is a nice platform that's extensible. Acquired by Red Hat, over a year ago. And it really is, in my opinion, the lowest barrier to entry in automation in terms of systems and network automation. Within minutes, you can literally be automating a portion of the network. And like I said, anything we're going to show tonight in Ansible, you can clone that, get a repo that I have for tonight, and just copy them and test it out in your given environment. All right. OpenConfig. Anyone hear of OpenConfig? Data models. Awesome. So, big portion here. So right now in the networking industry, a big hype is not only automation, but just data models in general. There's terms like netconf and yang. Tonight I'm going to demo RESTconf, right? So some of these are protocols that are driven by data models. So OpenConfig Working Group is building vendor neutral data models, and there's a misperception out there that yang has to go with netconf and vice versa. But in general, we have an example of an XML object on this screen that shows what the XML representation is of a standard basic BGP model from the OpenConfig Working Group, right? So what that means is, in theory, this object in structured data in XML should be able to be pushed to any vendor's device if it supports that given model. The issue is here, if you look at these XML tags, config, BGP, global config, the issue today is those tags are different for every vendor. So it makes us be the integrators of being able to translate and map what vendor A calls AS. Like here, that says AS for the model, but one vendor might call it ASN, one vendor might just say AS dash N, and so forth. So in general, it's about normalizing this data and having common tooling that can be used across multiple vendors. So tonight, I'll be demoing a module that I wrote this weekend for this meetup that configures an iOS XR device with this data model. And I tried my best to have 2 different vendors in this demo, but unfortunately it's still early on in the industry. I would expect by the next iNOG or the next few months we'll have more VMs that are publicly available that support the OpenConfig BGP model, right? Postman. I'll show you this live. A Postman is just a Chrome plugin that makes it super easy to test RESTful APIs. And we're going to look at a RESTful API that's brand new on iOS XE as of 16.3. And again, this RESTful API we're going to look at is called RESTconf. Right, so RESTconf is a new type of RESTful API that exposes Yang models on the device. Okay. Cool. So we'll dive into the demo here. Oh, my toolbar's gone. Where'd I put the toolbar? All right, there we go. All right, I'm a Windows person, so everything I do is in a Linux VM. Haven't made the conversion yet to. All right, cool. So we're gonna I can probably show it on the GitHub repo too before we do this. But so we're gonna do a live demo of Ansible communicating and making a BGP configuration change on a Cisco iOS XR device. All right. So what this looks like from a Ansible perspective, we're showing here. I can enlarge this a little bit. This is our inventory file for Ansible. Right. So what we're showing here is different groups of devices. Right. So we have a group called VMX with 3 VMX routers, a group called iOS XE with one router called CSR1, XR, and then we have some global variables for credentials to log into all devices. So as an example, all those names in our inventory file for this demo, they're just an Etsy host. So all of these are in a little mini pod. So hopefully they're all still up. Okay, cool. All right. So we have all of these accessible. So this is our inventory file. So in Ansible, there's 2 files needed to get started. Inventory file is a pretty basic file, INI-like file. The rest of the files in Ansible would be based in a YAML structured data format. So here we're looking at a simple playbook that just has a single 2 tasks in theory. So we have, again, this is the single file right here. All right, so a few things up top, we're giving this play a name in our playbook. And this is just arbitrary text that'll be displayed when this playbook runs. Right, that's all it is, totally arbitrary. Host here, iOS XR, this could be any device or group defined here. Right, so if we happen to have XRv2 and so on, then calling the group iOS XR would automate all of those devices. So this is a simple task, configuring ASN and router ID. So then in a matter of seconds or minutes, it would deploy the same configuration or bad configuration on all those nodes. Okay. So this is where the mapping happens between inventory file, right, and playbook. Okay. Connection local. These two are used for the most part when we're automating network devices, because the way Ansible works is a little bit differently when we're automating servers. If it was a server, we would be SSHing to the device. Here we're going to be using APIs under the covers. And specifically here, we're going to be using netconf to talk to the device. And again, the XML object that we're pushing to the device is based off of the OpenConfig BGP model. Okay. So we have a single task that we'll highlight right here. So the single task is going to ensure it's really technically singular. This device has a proper ASN and router ID. Right, so this text here, this name, is arbitrary, and we'll see this in real time when this playbook runs, where the names get displayed. Then this is the module called OCBGP. So this is an OpenConfig BGP model. Okay, so again, this is brand new, open source. past few nights, sort of, put this together, for this talk, trying to do something a little bit unique and different. And again, the end goal is to be able to use the same module to automate, let's say, the XR device and another vendor. Not there yet in terms of vendor support, but the nice thing is this task, should work if the other vendors support OCBGP models, which they do in development, just not yet publicly available. And the difference here is if we looked at certain tasks today in Ansible, like we would see things, let's say VLAN configuration, like we would see things like this. We would see NXOS VLAN, we would see like VLAN ID is 10, other parameters, VLAN name, credentials, and things like that. If we wanted to configure, let's say, Arista VLAN, this is one option, other modules exist, but typically it's going to be OS underscore and then some resource or task, okay? So that's the real value, is the abstraction is now in this vendor neutral data model, so we don't have to worry about, well, what JSON key value pairs are being used or XML tags are being used by a given vendor. If they adhere to OpenConfig or a vendor neutral data model from IETF, whoever it is, then a common module can be built to automate those tasks. Okay. In general, this is really, let's see here. Actually, I think it's configured. Let's just go to it real quick. Actually, what we'll do is, so there's two states here. One is present and absent. So we're just going to run this first and ensure it doesn't exist. Okay. So to run a playbook, we'll see the statement to do that. Okay. OCBGP. Ansible playbook -i, our inventory file, which is called inventory. We see that in the top left, and our playbook name, which is called OCBGP.yaml. If we see a stack trace, I apologize. Again, this is fresh code, written just for the Irish. So right now in the back end, right, this is making a netconf connection to the device, and the way modules should be written, they're meant to be idempotent, so it would only make the change if it has to get made. So there's more intelligence than just pushing an object, right? We have to get the current configuration first, compare a proposed state to the current state. If it's different, then push the change. All right, so we see here this is okay, so nothing actually happened. That scares me a little bit. So let's just real quick, maybe I did delete it before. I don't know. If not, we'll just pretend that works. All right, so we're gonna run this one more time. I'll skip doing the check on the device only because I want to get through the other playbook and then post them in as well. There's some neat things there to see. But in general, right, so it's going to go back, connect to the device, do the comparison, and then push. Yeah, so this is being okay. It could be my change flag, might be true. It could be returning a changed false, but it really is changing. But in general, this would be the methodology if we had modules written that supported these vendor neutral data models. So this is like the real value versus having to worry about, well, is it this vendor or that vendor, right? We can have a common task, tool, or framework to do that. I'm just using Ansible as the vehicle to do that because it's fairly extensible to rapidly build integrations like this. Okay. Next playbook I want to show is going to automate the 3 VMXs, right? Not pushing configuration this time. This here we're going to do the automatic cable verification. So again, the hard part here is defining topology up front. All right, so we're going to include and import variables from a third file that we call topology.yaml. So here, there's more ways to do this. There's more programmatic ways to do this as well. This is just, again, my way of doing this, for the demo. So we're defining here what the topology should be, right? So this is a format I defined desired, VMX 1, 2, and 3 on each interface, what the neighbor should be, right? So we're going to go to the device now, look at their playbook. There's a few things going on. We import those variables. We're going to use a Juniper module in Ansible where we're going to gather the neighbors in real time. There's some debug statements in here. We're going to bypass that for a little bit. At the bottom, though, there's this assert module in Ansible that is really valuable and often overlooked. Right? We hear a lot about unit testing and software development. We can assert certain things. We can assert certain things in playbooks to ensure the network is in a given state. So the nice thing is you can assert configuration data to ensure the configuration is correct, or assert operational data. Right? Again, pre and post change. You want to ensure adjacencies or X, Y, and Z after a cutover or reboot. You want to ensure BGP routes don't deviate by more than X%. Whatever it might be. Like those things are possible. right? With tools like this, it just takes, a bit more time to get it developed and to get it functioning within a playbook, right? So in this one, I'm not using any custom modules, right? Everything. So this one can be used, tomorrow in a production environment, right? So the GNOS get table right now, you would get cloned from Juniper on their website, on their GitHub site, and then assert is another core module, debugs core modules, things like that. So here, I can't go into in terms of time, but there's ways to manipulate data and access data in different locations in Ansible. That these assertion statements are saying that we want to do 2 checks here. We want to ensure the same quantity of neighbors exists in the existing states in real time, as well as the as well as the desired topology in our YAML file. And the second one is actually ensuring that the neighbors are the same. Okay, and we can get more detailed if we had more time to build more tasks, right, to help with the output. But if we scroll back up, I'm going to try to save the time typing it again. There we go. Right, so same format. Writing the playbook, or executing the playbook. Ansible-playbook, inventory file, the name of our playbook. So if we run this, again, this is going to go out right now, communicate to all 3 VMXs. So the first step is there. So this is all green. So these assertions, like if we went to a device right now, rebooted it, shut down interfaces, these would be red, right? So we look at this. We're getting real-time neighbors. We have some debugs that we're skipping for now. We have some conversions going on in terms of data types to make it more usable, within our playbook. Then we have, this is our assertion, right? So these are all of our assertions because we're looping over every device in our desired file. So right now we know our cabling is correct in this topology. Or hypothetically, again, if this was top rack devices, we can even add ESX hosts in here or whatever hosts are being used. That as long as the vSwitch supports, LLDP. Okay. So that's pretty neat. All right, cool. We're going through this fairly fast, but the one last thing I want to talk about is a newer API on iOS XE, right? A really new API. So right now, the new fad, right? RESTful APIs and SDN controllers, things like that. So if it's Cisco ACI, VMware NSX, Juniper Contrail, all these platforms, right? Arista Cloud Vision, all these things have RESTful APIs, right? But even network devices can have these RESTful APIs. And when we hear RESTful API, for the most part, we're referring to some way to communicate via HTTP to the device, right? Instead of SSH, instead of netconf, instead of SNMP, we're now going to use HTTP or HTTPS to communicate to the device and then get structured data back, right? So web calls, browsing a website, you'll get HTML back. Here, we're going to get JSON or XML back, okay? So if we look at a quick little demo here, I have another device in the public cloud, right? Its host name is CSR1000V. And so this here is not using a vendor neutral data model, right? So this is using a model that was built by TailF. Cisco acquired them, right, a year and a half, 2 years ago. And so this model was built to model the full running configuration in JSON or XML, which is pretty nice, okay? So the first thing, if we do a get, right, so we see the full URL here. And we're adding a query parameter to ensure we get the full configuration, basically all they call them leaves, right, in terms of Yang terminology. So we just got back on the bottom half of this screen. Let me try to scroll down. This is, again, the TailF, folks who have heard of TailF. We have NED. This is the network element driver, the native one for iOS XE, right? So this is a full running configuration as JSON, which is really, really nice. Because one of the hard parts right now in terms of managed configuration is like how do you negate something on the device? Like, does it require a no? Can you just replace that command? That's one of the hardest parts about trying to automate different tasks in the network. You can't just push the same command. You have to figure out now how to negate it. And using true APIs, a lot of that goes away. Okay. So this API call, this was HTTP GET, right? So we just have different HTTP methods here being used on the API. Right, so this is a RESTconf spec being used. So the really nice thing here is I'm a huge fan of what we can do with, let's say, a patch and a put. So these are standard web verbs that are being used now against a network device. So here we have a patch. This patch and this syntax in the JSON body is going to patch or add these two static routes to our device, right? So if we go to our device, real quick, we see we have a single route in here. So if we click send here, we see our 204 down here, and we see now two routes have been patched or added, right? The really nice thing here, this is what I'm personally a fan of, is if we change, same URL right now, all we did was have a default static route in this object. We changed the verb to put. Put is most analogous to have declarative network configuration, meaning we don't care what's currently on the box, but we want to ensure this is the only static route in the static routing table, right? So if we do ascend here, we'll get 204 no content. Now we're back to our default static route. And a lot of folks would prefer to use patch all the time, right? It's just the safer bet. However, if you truly can use puts in the environment, you can care less about what's on the device and just declaratively state this configuration is what should be on the device, right? So it's a huge win in terms of managing networks from a source of truth versus making the devices, be the source of truth. Okay. All right. Awesome. Perfect timing. That was it.
Great stuff. Thank you so much, Jason. I think we'll probably just do one question, but then obviously people can go and tap Jason after. Has anyone got a question in terms of Ansible, or anyone straight out? You can park it, and we can go straight on to Rodrigo for the next one, just in terms of time. Is that all right?
Yeah, I'll be around.
Thank you so much, Jason. Thank you once again.
Thank you.
Okay, so the last talk of the evening, we're just going to get changed over. Stretch yourself a little bit, maybe grab a quick drink. Rodrigo from RiotGames is going to give us probably more than an overview of why the internet sucks. Okay, guys, we're going to kick back off again. So if you can grab your seats again, settle down. That worked. So I'll hand you over to Rodrigo for the last talk of the evening, and then we're going to do a bit of socializing after that. Thank you so much, Rodrigo.
Thank you, Donal. First of all, welcome everybody. I finally got set up, so let's get this started. Welcome. I'm going to go through with you why the internet sucks. I'm going to try to not suck as well. I'm a bit nervous, But yeah. So why does the internet suck? Or at least it did for us. This will not be a very technical presentation, but it will explain the problems we faced with the growth of our game, the growth of our player base, and the growth of the internet. How we tackle those, and how we're trying to solve those problems. Yeah, here we go. So this will be the screenplay followed. First of all, why the internet sucks. Then understanding how the internet works, at least from our point of view. What we did to try to fix that, and what we'll do in the future to allow us to grow even more. It's a very self-centric presentation, but yeah, this is our history, so yeah. Cool. So, why does the internet suck? Latency, very important for gamers. Okay, if you're a gamer, you've probably experienced this, where you're on your computer, you're targeting an opponent, you're pretty sure that you're going to hit him, but yeah, what really happens due to lag is you throw your shot and the opponent already dodged it. The same thing happens when you're trying to dodge some opponent hitting at you. You're pretty sure that you dodged it, but no, the arrow is already in you, and in both situations on our forums, we get players flaming us, Rito, please, what's happening? So yeah, latency is very important for us. And in terms of latency, this is a heat map of where we were at in November 14. So let me go to my notes. Dark green. Dark green was under 30 milliseconds latency. Light green was 30 to 60 milliseconds. Yellow, 16 to 90. And orange, 90 to 120. Above 120, it was red. Our servers were located in Portland. Let me use the magic pointer. Right about here, and or even lower. And we see, you know, kind of a good, nice green patch around there, but there's inconsistencies all around. Even here we see some orange there, you know. That group of people was very happy playing at very low latency. So, and what did we see? So when we should get 14 milliseconds latency plus the access layer, it should get us about 30 milliseconds later to latency to a player. We were actually getting 10 plus 26 plus 30 plus 4, you know, around 70 to 80 milliseconds. So even though they were geographically quite close to us, you know, they still lagged. So this, we had to really fix this. Again, State of Europe back in 2014, very colorful. And this is a problem we tried to tackle. Why does this happen? Now let's talk a bit about routers. We all know them and love them. They're the workhorses of the internet, very specialized root processors that have to basically process every packet that goes to them. And does that matter for us? Yeah, it does, because packet size matters. You know, for some things, size really does matter. And for us, it mattered a lot. So standard web traffic, 1,500 bytes, large packets. Actually, the average on the internet is around 600 bytes. Yeah, our traffic is very small, 50 bytes. So for every 1,500 bytes of a large packet that passes a router has to process around 30 of our packets. Yeah. So we can kind of overwhelm routers with our traffic. And so we had to kind of fix this. For congestion, routers normally use buffering. The problem is most ISPs don't buffer UDP. So yeah, again, we're kind of at a loss there. Yeah, there you go. Especially when we do something like this. We introduced a new game mode, and from one day to the other, our traffic increased about 40%. Last point, routers kind of work not in a vacuum, but they look at the network from their own point of view, and they make their decisions based on their own point of view. We would like more, you know, if they would look at the whole path and really control the quality and congestion based on the whole path, but that doesn't really happen. So what does this mean for us? Yeah, player accessing our game, outbound path towards our game servers, it goes all over the internet. Return path, again, the same thing, you know, and these are decisions that the provider kindly does for us, which really benefits the provider. It doesn't really benefit us. And this makes a very sad player. Add to this DDoS attacks, congestions, it's just a mess. How do we compare to Facebook, Apple, Google, other content providers? We kind of don't, because they deal in the big size things, big data chunks being sent. Video, audio, those can be prone to buffering and maintain quality. We compare more to real-time trading companies. Small packets, latency in real time really matters to us. So what did we want? We really wanted this. So we tried to build that. What did we do? Our goal was to get 80 milliseconds to all players. And how did we come up with the 80 milliseconds? So we took some lessons from audio testing. So if in audio, if you have feedback on your audio, and actually some fun companies do that on your phone so you don't speak as loudly, you hear yourself speaking and you control your tone. If the latency between what you hear and when you're speaking is under 80 milliseconds, 60 to 80 milliseconds, you notice nothing. Most humans don't notice anything. If it goes above that, you start to feel the echo, okay? Again, from visual testing, if the lag between video and audio is under 60 to 80 milliseconds, you notice nothing at all. If it goes above that threshold, it starts to feel dodgy. So let's watch a movie.
Reporting in. Welcome to Summer's Rift.
Everyone's played a game where at some point a person on your team with the enemy team is disconnected and come back and made the excuse, sorry guys, I was out for 5 minutes because of lag.
It created an environment where players got frustrated simply because of something that had nothing to do with game at all, and that was their internet connection.
We'd chosen to put the game servers in the Portland area of Oregon, which meant that a big chunk of the North American population was actually pretty far from those game servers.
Even if players were close to our data center, their latency could take them 100, 200 milliseconds instead of taking 14, which is what it should take from, say, San Francisco.
Carriers, when they receive messages from that user to send on to a content provider like ourselves, they want to offload that as fast as they can to use the least amount of, say, circuit miles as they can.
And we started understanding that Netflix and some of the other big content providers were struggling to get packets through to their customers. They get to buffer that content. Our game operates much more in real time. We don't benefit from buffering, and so packets start just disappearing. And when packets starts disappearing, it manifests as lag.
With anything, we always start with the player experience. And when we thought about the connectivity we have with our players, we wanted to find a way to really improve that experience.
The project was exciting because it was about improving performance and to sound really cliched, about making the internet better. How can I genuinely work with companies to improve performance of a product for our players?
We really had to level up our internal capabilities in order to address this complex issue. And because of that, it was natural for our teams to really start banging their heads against the problem and the question of like, hey, is it possible for us to build a better backbone and infrastructure and improve the network?
We looked at the cities around the USA, looked at the regional traffic hubs, where other carriers connect together, where people host all their servers, host their content.
And what we did was we put in routers at those locations. Now what this meant was we were reaching out to places like Comcast or Time Warner Cable and literally directly connecting a piece of fiber from their network into ours. And instantly we saw that we were able to drop latency for players, in some cases up to 70%.
One of the things that is hard to metric is uptime. When people sort of think about the problems we had with DDoS back in the day, posts on Reddit, posts on boards, right, your servers are down, what's happening, your network's terrible, your servers are terrible.
Having a backbone where we can actually protect at an edge that's further out from our own data centers really allows us to harden ourselves against those types of attacks. Of course, there's no bulletproof solution that solves everything, but this has definitely helped to improve our capabilities in this particular domain.
We've had some great results. Our players across both North America and Europe are experiencing much better connections to the game. And we used to have an awful lot of complaints about latency and packet loss and things like that, and those have really trended down over time.
Like, we see better retention, we see more gameplays, we see players just investing more time and enjoyment in the game as a whole, and that's really what we're all here for.
I think the biggest thing players will notice now is they do have a more consistent experience. They won't have changes from week to week in their ping time and in the performance of their gameplay.
You know, the engineers on the Riot Direct team are always on our forums and on Reddit and watching to see player reports coming in so that they can work with them to really identify where these biggest, the gaps are so that we can optimize those over time and improve things for players.
One of the cool things that happened, there was a player in the New York area that started posting some really incredible things. It was clear they had a network engineering background. It was clear they loved League of Legends and understood the mechanics of the game and how the network could affect it. So we brought him out for an interview. He decided to move, and now Riot Direct's got this, what I would think of as almost a near perfect hire for Riot. Great player, understands the space, understands the problem, and wants to solve more problems for players.
The game has actually changed because we've created an environment where we can build more nuance into the way champions are built. And it allows us to do things like, if you look at new champions like Gen, there's more nuance in Gen than there have been in other champions because we have a more consistent experience for players.
Yeah, we think the future is pretty bright. There's still a large roadmap of things we want to do to help improve the network experience for our players. But then we're also sort of toying with the question of whether or not this is something that, from an infrastructure standpoint, can of course expand beyond just League of Legends.
As games continue to change, or as Riot does other types of content, this is an investment that's going to provide us a lot of capability to ensure we have great experience for players.
We're going to try to take everything that happens when you interact with gaming, when it happens on a Riot Direct network, and make it as efficient and as pleasurable as possible. And that means that we're going to have to look at things both from a service provider network perspective, but also from the vantage point of gamers. Service providers might have built out their networks a certain way, but maybe that wasn't the right way to do it. Let's think about what we can find that can make these things even better.
Now with sound, even better. So this was a bit of what we did. I'll share a bit of more information around that. So this is our Riot Direct map at the moment in Europe. This is our map worldwide. We have plans to expand this so we can reach not all, but the majority of our player base and really have an impact on their player experience. So this is the impact we had up until, not now, but in NA in the first year, back in 14, we increased from about 30% that were below the 80 millisecond limit that we imposed to about 50%. Today that number is at 85%. This is the map that I have already shown of EUW, one of our European shards in 2014. This is how it looks now. The same thing for our other shard, UNE in Europe. This is how it looks now. Yeah, things look a lot better. Our work isn't done, not close to it. A lot of things to be done still. Some words around peering, and that's a constant worry. This is usually what we want to see. When we peer with someone, we want to see dramatic improvements upon that peering. Unfortunately, that is not always the case. Sometimes we have erratic peering. Why does this happen? So suppose, for example, this graph depicts a very large provider covering the entire Europe, for example. When we peer for them, with them in a certain location, that might improve the connection to the players around that geographical location. But if that provider starts sending us all the routes via that geographical location, that might impact players in other places. This actually happened to us, not once, but several times. For example, we paired with someone in our Madrid POP, and the Spanish players and Portuguese players were ecstatic. But in Poland, player ping increased. Why? Because players from that provider and the routes of that provider were getting pushed to all the way to Madrid and up to our peering connection, and that is not actually what we want to see. When you add more providers into the mix, more complex these relationships become, and more difficult things are to manage. But we're trying to do that. What more can we do? We are working in automation to deploy POPs faster, have faster peering, get more results and more reliable data from that peering. We have a lot of data analysis, almost real time now, checking player connectivity from all our player base, monitoring the number of hops the players take to us, their latency, monitoring providers, and we are trying to tie all that up to automation so we can dynamically react to everything that goes on the internet. We're building more and more robust DDoS systems to protect the games for our players, and we might build our own routers in the future, who knows. So thank you everybody, hope you liked it. Time for questions. And just as an add-on, that player that got hired by us, it's right over there, is Aaron. I'm going to ask him up to the stage to help me with the Q&A.
Okay, cool. All right, well, maybe we'll give Aaron this microphone. I'm going to send around the catch cube or catch box. Has anyone got any questions? We got some at the back there. Hang on one second.
Thanks.
Aaron, I'll give you this one. Hi. Thank you. Oh, is this on? 1, 2, 1, 3, 1, 2.
Hi. So did I understand right that initially when you didn't have any optimization, that players which are more farther away from the network experience actually more consistent behavior of the game?
Sorry, can you repeat that?
The players which are more far away from your servers, they experience more consistent
no, that's not always the case. So as expected, the farther away the player is, the greater the latency. But that wasn't consistent. So players closer to us might have higher latency than we expected, and players further away, because their providers made some different routing decisions, might be better connected and have lower latency to us. What we, from start out, not only we wanted to decrease all the latency for all the players, but we also wanted to increase the consistency of the player connection and make the routing decisions less dependent on the provider and more dependent on what we do. Do you have anything to add?
No, yeah, that's exactly right. What we built out took out the inconsistency of the internet. We take players on as quickly as possible from their ISPs in regional areas, put them on our backbone. So we know there's not going to be packet loss or high latency. So we just take the unknowns out of the internet with our network.
So is it correct to say that the experience is not only due to delay, but also due to jitter?
Packet loss is huge, yeah. It's real time, so if you lose a packet, it's not going to be sent again.
And the jitter, so the variation in the delay?
Absolutely.
Okay.
It makes a difference.
Thanks.
Yep.
In terms of jitter, if there's the variation on jitter is low, it doesn't really impact us so much as voice, for example. But if you're at 40 milliseconds, for example, and you jump to 80 for a bit, and then you turn down again, yeah, it impacts the player experience a lot. Yeah.
Hey, so you said that when you released the new game mode, my name is Lorcan. You said when you released the new game that you saw a 40% increase in traffic. Were you expecting that kind of increase, or was that completely unexpected?
So it's not only about analyzing traffic patterns, it's on analyzing player behavior as well, and that sometimes is quite unpredictable. Some game modes, some changes we do in our game are very well received. For example, in Korea, while the players in NA don't like them at all. And of course, when we launch any new game mode, we hope, it's a success. But sometimes the success comes back to hit us hard.
Yeah, and the game mode we released was called Ultra Rapid Fire, or Earth mode. People love this game mode. I would say 40% was a little unexpected, but it's really cool. It's a cool problem to have. But so I don't know if we knew 40% were coming in.
Actually, this is pretty much related to that. Sorry, Richie. So with Earth, do you have to see a higher packet load? So I'm assuming because all of the abilities are spammed a lot faster, do you have a higher number of packets per second coming through? So do you have to ramp up your backbone, or can you scale things out? How do you deal with that?
So the it's not so much related to the complexity of the game itself, even though it has some relation. That load is felt greatly. It's felt more on the actual game servers and in the amount of memory the game occupies in the server than the actual traffic. It's just people playing more and more times and playing,
So would you have already
the
allocated
adoption of the actual game?
Would you have already tried to earmark enough of the network bandwidth that you'd have to deal with the amount of updated packets per second that the game server would have to deal with, or?
So capacity-wise, we're pretty good, actually. We're covered capacity-wise normally. What I do understand is we have some game servers on standby, ready that can be spun up.
So you have a pool.
The game servers start getting overloaded. So this past weekend, we had that ready because it was actually all random ultra rapid fire mode, which was a new thing for us and was actually pretty positive as well from what I've seen. Yeah.
Another thing in terms of capacity planning, we usually give ourselves a very, very big leeway, especially to allow us to absorb very large DDoSes. So the leeway we give us is, 60
it's
to
a lot.
upper.
Yeah, we don't get anywhere near network capacity just so we are protected from DDoS. So yeah, but servers, that's a great question because they do have those on standby.
My name is Kosti. Have you considered a cloud-based solution?
Oh.
Are you from Amazon Web Services?
Try again. Keep trying. You'll get in the top 4.
I get it. Yeah, I get it.
So we're not tied to physical hardware and physical network devices, and so yes, we are quite open to cloud-based solutions. We use them quite a lot, but all the traffic comes to us via our Riot Direct backbone. Of that we won't give away, at least for now, and I don't imagine us doing so because it gives us the ability to traffic engineer and manage the traffic and also in relation to DDoS, no one knows our traffic better than we do, so we can put our own solutions in place and passing all of that to a third-party company that might not be as player-focused as we are could be a problem. Yeah. Anything?
Yeah, actually, but that's a good question. We do have a mix. We do use some cloud services. We have our own stuff, but we also are kind of building our own cloud. And it's a timely question because I don't remember the URL, but if you Google Riot Engineering blog. One of our guys just put out a blog yesterday talking about some of the services in the cloud that we do use and don't use. So yeah, more info out there.
Sorry, Donal. From this quite extensive world latency data, you presumably have some idea of a topology of how the internet is rather than the actual layout. Have you looked at moving your data center to more central points, so you're at an area which I presume is a bit away from, there's a known West Coast, East Coast interconnect, for instance, would it make sense, or do you just, is it our decisions you make and where you actually locate?
No, yeah, then that's a good question, because we actually did move our game servers. We moved them to Chicago, to a more central location, due to, even with all the changes in the right directing place, East Coast players to West Coast players and to go all the way to Portland still caused an imbalance in quality. So yeah, we moved all our game servers to Chicago, to a more central location. We're thinking of options to explode that and get our game servers closer to our POP locations, or even in our POP locations for the future, so we can decrease even more that latency and dynamically steer the players towards certain game servers closer to them.
So next iNOG, you're going to present how you bit physics, right? Okay, these guys will be around the whole night. Sorry, we need to wrap this up. Yeah,
cool.
Please, if you don't mind. We'll be here for another hour and a half anyway, so please grab them and ask them any other questions. Round of applause. Thank you very much. All right. Donal stole all the spotlight at the beginning, so I will steal the ending credits. Normally, this won't take long, I swear. It's fine. You already ate a bit, so you shouldn't be in a rush. I actually should have about half an hour, right? I could do a short act, do a bit of tap dancing, something like that. No. So first of all, a massive thanks to Riot for hosting us tonight. It's a great turnout. Yeah. A second round of applause for our speakers. And the third one for all the people that actually helped us tonight with AV. Our man here has been awesome. We had a few of the older members in the community help us a lot with greeting people and signing them in and signing NDAs and all that scary stuff. Yeah, so your work is very much appreciated. As probably Donal has said, this is a community effort. This is a volunteer-based effort, and we appreciate when everyone steps up, and as small a contribution that you can make, it's always appreciated and welcome. So speaking of contributions, as usual, we're looking for new and exciting places like this to host our meetings. We have these meetings about every 2 months, and we've been treated really nicely by all of our hosts up until now, which means that we're looking for even more other awesome spaces and awesome companies to show us what they built. We're looking for presenters and talks. Anything that would be of interest to the community, be it technical or non-technical, is very much welcome. So if you have a talk that's 5-10 minutes, 20 minutes in length with a demo, without the demos, that sort of thing, please get in touch. iNOG.net. You've got a few ways to get in touch with us via Slack, via Twitter, via email. So please let us know, and we'll be happy to schedule you for future meetings. We also have a program committee, which is basically a group of people that are helping us with various things that myself and Donal don't have enough time to deal with or would like to do something about. But again, this being a volunteer effort and us having day jobs, it doesn't always work very well that way. So again, if you have a bit of time that you would like to put towards iNOG and towards improving it and to adding more content to our meetings or to things outside of the meeting, like our workshops on online, please get in touch and we'll find something for you to do for sure. Don't be worried about that. There's the list this long. As usual, there's going to be a short survey going out. It's 3 or 4 questions. It's literally half a page. It takes you 1 minute to click through it. We'll appreciate if you fill it out and let us know how we've done and what we can improve. Our next meeting will be hosted by SIG. It's on the 24th of November. And you might think, okay, iNOG 9, it's going to be iNOG 10, right? No. We started with two columns, right? So you should probably see what's coming now. So we're going to have iNOG A next time. So iNOG A, 24th of November, registrations are open, the polls are open, go vote, say yes. I'm looking forward to seeing you there. Thanks again, everyone. There's a bit of extra pizza at the back now, and I think some more sweets. We've got until about 9:30 for socializing time. So thank you very much, and enjoy the rest.